Hi everyone, welcome to Unit 5, Mod 23. We're going to talk about sleep today. So here are your learning objectives, and here is your vocab. So let's get started. The circadian rhythm is the key thing that regulates our awake and sleep cycle. So this is an internal clock, and we'll talk more about this in a little bit, that basically synchronizes with the day and night, with sunlight and sunset. This is different depending on our age a little bit and a little bit of our experience, but our body releases hormones and alters because of this circadian rhythm. And this diagram here I love because it kind of shows you, it works you through how at different parts of this 24-hour cycle, our body is doing different things to help us wake up or go to sleep. So for example, it says at 9 p.m. our melatonin secretion starts, and melatonin helps us fall asleep. Not stay asleep, by the way, but fall asleep. And our blood pressure is rising in the morning, our alertness, our coordination, all of that is happening closer to full daytime, right? So noon. So when we are talking about sleep, we're going to go through 4 sleep stages, which you do need to know. So the sleep stages go every 90 minutes. We cycle through these. So if you look on this chart here, it shows you EEG brain waves that we would see if we were looking at your brain from awake to asleep and through these 4 stages. So the first one are those beta waves, those little tiny waves. So that's an alert wake state. That's what we want to see when you are watching this video. When you are having alpha waves, you are awake, but you are in this restful state. So think of like when you're in bed and you're not asleep yet, but you're in this relaxed state. These waves also show when someone is meditating. Then you go into the theta waves. So those are the slower waves during our non-REM 1 to non-REM 2. And non-REM 2, they'll see bursts of what they call sleep spindles. So if you look towards the end of this non-REM 2 wave, you'll see like a big high and low at the end. That's a sleep spindle. So rapid brain activity is occurring right there. And then delta waves are the deep sleep waves, and those happen in non-REM 3, which is our deepest sleep. And then you can see REM actually mimics a little bit more of an awake state. So we're going to talk about that. So REM sleep, or rapid eye movement, is also known as paradoxical sleep. And that is because our body is at rest still, but our brain becomes active. So we are asleep and our body is paralyzed and the brainstem is not sending any messages, but our brain is trying to send messages. So for example, our motor cortex is active and it's trying to send a message to tell our feet to walk or our hands to move around and whatever. And our brainstem is blocking that message. This is also the stage of sleep where we dream. And this stage of sleep lasts about 10 minutes long. I know that you think you've had really long dreams before that have definitely gone over 10 minutes, but you don't really have a sense of time when you're sleeping, and so it just feels like you had a really long dream. You'll also notice if you look at this chart over here, if you just look at the top one for now, you notice that the amount of REM sleep increases as the person is sleeping longer. So the more you sleep, towards the end, you're having more and more time in REM, and it's lasting longer. See how it lasts a longer in that last one versus the first REM sleep. So non-REM is all the other parts of sleep. So non-REM 1, 2, and 3. So this is non-rapid eye movement. Okay? Fun fact, we don't remember the moment we fall asleep. Actually, kind of weird, right? So in non-REM 1, you can have hallucinations. So hearing, seeing things that aren't actually there. And we can also have these hypnagogic sensations. So, for example, a really common one is the sensation of falling or sometimes floating. And that is that feeling as you're entering non-REM 1. So during REM sleep, like I said, your body is immobile. You can't move it, but your brain is active. So something can happen there sometimes where you enter a state where your brain is actually awake, but your brainstem, it hasn't caught up yet. So your brainstem is still blocking that message and you're paralyzed. So people find this extremely uncomfortable and kind of like an not a good feeling. And they report like seeing things or feeling things, whatever. Sometimes they report like a heavy feeling on their chest because they're paralyzed. They can't move their chest. So our sleep patterns are also, they're not just by sunlight, they're not just by when we decide, they're both nature and nurture. So there is something called the suprachiasmatic nucleus, actually the nuclei, because there are two of them. And they are clusters in the hypothalamus that control our circadian rhythm. So when we're talking about that circadian rhythm, that pattern, we're talking about the suprachiasmatic nuclei actually controlling that. So adjusting our melatonin production according to that day-night cycle. So things that can interrupt that are like artificial light. So they notice when they look at over time people's sleep patterns, they notice that the invention of the light bulb, for example, has caused us to stay up later and actually sleep in later too. We also notice that sleep patterns are genetically influenced. So issues or quality of sleep that your parents have or that's just in your gene pool, you are prone to have also. And sleep is culturally influenced. So we kind of learn how and when we should do that based on what our society tells us. So there are lots of different theories about why we sleep. So for one theory, think in evolutionary terms, we sleep because it protected us. If we slept at night when it was dark and we couldn't see well, we were protected from predators. And we were also protected from climbing and walking on things that we could fall and break our leg. Sleep also helps us recuperate. There's actually a lot of research on this, how it restores and repairs our brain tissue every night when we're sleeping, so super important. It also helps restore our memories. There's a lot of research on this. When we talk about memory, we'll talk about this more, but they did a study where one group took a nap after learning information and the other group did not, and they were both asked to recall the information, and the group that had napped could recall the information better than the group that did not. So even over not a long period of time. So it also helps our creative thinking. You get a good night's rest. Your brain is able to solve problems more insightfully. Sometimes you get stuck on an issue and maybe you go to sleep and you wake up the next day and it kind of comes to you. That's insight, and we'll talk about that. And that sleep helps promote insight. Sleep also supports growth. So babies and children especially need that deep sleep, that non-REM 3 sleep, because that is when the pituitary gland is releasing growth hormone. And that's very important for children. Okay, so our takeaways. Sleep is both a product of nature and nurture. You should know the 4 sleep stages: non-REM 1, 2, 3, and then REM. And by the way, non-REM 1, 2, and 3, when you're going to REM sleep, you don't go from non-REM 3 to REM. You actually go non-REM 3, non-REM 2, and then REM. If you go back and look at that chart that it shows you the young adult versus the older adult sleeping, you can see that it stops at non-REM 2 before going to REM, and then it goes back down. You should understand the importance and function of REM sleep, know the theories of why we sleep, and that's about it. We will be talking more about sleep in class, and then our next module will be talking more about sleep disorders and dreams. All right, so I hope this was helpful, and I'll see you in class.